Okay, so you've learned the basic techniques of integration, just the basic formulas, and now we're going to take another step, and we're going to use something that we often call U substitution. And we use U substitution when we're trying to integrate something that would have been, you would have gotten it by taking the derivative using the chain rule. Okay, so this looks a little funny, but if your integral looks like something where you've got a function composed with another function, so f composed with g, and then you've also got the derivative of the inside function, okay? This would be, this is the formula you see when you're taking the chain rule, right? And we're kind of doing the backwards chain rule here. Then we say that's the same, you're going to let u equal g of x, and then we say, well, we take the derivative and make sure that's there. U prime would be g prime of x dx. And now what we're doing is we're saying, okay, well, f composed with g is the same as f composed with u, and this g prime of x dx is du. That's what this u prime is. That's the same as saying the derivative of u. Okay, so then we can integrate it. It's something that we'll use the simple formulas to integrate. And then wherever we have a u in our after we integrate, we'll plug back in g of x. Okay, so we're going to look at this first one. We've got the integral of 2 times 2x plus 6 to the 5th dx. So here we're composing our f of x would be x to the 5th. Our g of x that we're plugging in there is 2x plus 6. And we know that g prime of x is equal to 2, which we have. Well, we'd say 2 dx, which we have right there. Okay, so how we do this is we say, okay, let u be equal to that inside stuff that you have the derivative of somewhere too. So 2x plus 6. Then we say, okay, du is equal to 2 dx. So the derivative, and then you put a dx. So now doing the substitution, we can say that original integral we had is equal to, well, this right here is u to the 5th, and the 2 dx is equal to our du. Now, that's an integral that we know how to integrate. We know that this is equal to u to the 6th over 6 plus c. Now, our original integral was in terms of x, so we need to get this back in terms of x. So we look back and see what u was equal to, and we see that u is equal to 2x plus 6, so we need to plug that in here. So our final answer here would be 2x plus 6 to the 6th over 6 plus c. Now, we're going to see an example here where I said you had to have the derivative of u, but you actually just have to have the derivative up to a constant multiple. So we're going to look at x sine of 3x squared dx. So we always make our u kind of what we're plugging into something. So our u here would be 3x squared. Now du, the derivative of that, would be 6x dx. Now, we don't have 6x dx, we only have x dx. So we always want this right-hand side to match what we have up here in our integral. When we just have a constant that's different out in front, we can divide both sides by 6 here, multiply by 1/6, and we can say that instead of plugging in du, we're going to plug in 1/6 du. Okay, so now we'll have the integral. We have sine of u. And then for x dx, that's equal to 1/6 du. So you can put the 1/6 out in front. You can always put that constant out in front. Du. And now we're going to integrate this. So we'd have 1/6. The integral of sine is negative cosine of u plus c. So we could write this as negative 1/6 cosine. Now u was equal to 3x squared. So we'll plug that in plus c. Okay, so that's how we handle it if we have a constant multiple of the derivative.